So this lecture is devoted to surface waves. So previously we have analyzed body waves, P waves and S waves, primary and secondary waves. P waves, it's also compression wave. S is a shear wave. And now we will analyze surface waves. Uh, those waves are really important for us because the most part of wave energy that we can find that lead to destruction of buildings uh, are in those two waves. Those waves called a relay and lava wave. And further, we will deeply analyze both of those waves, but one more point that I want your attention to. So, first of all, those waves take those places near the surface of our planet. So, that is why they are so important for us to analyze their impact of our constructions. So, and here you can find how those waves are moving through the ground near the surface of our planet. So, lava wave, it is fastest surface waves, and it is shear wave. So it moves in horizontal wave. It moves like snake. So the movement of the surface of our planet is like this. So snake movement, snake wave. But as you can see, at the top of the of the surface, the movement is higher compared to the deeper zones of continental or oceanic crust. Here is this movement. And this shear movement is really important for us to analyze because these impacts are really significant to buildings or structures that we are designing or building on those territories which are imposed to such waves. And here is the movement of ground particle. Also, we have to consider one more seismic wave, which is called relay wave. It is also wave. It's also surface wave, and as you can see, as deeper from the surface we are moving, the less movement or less motion we can find. So near the surface, it is this movement is bigger, and as far from we move from the surface, then less those movement or those motion of the particles we can find. So. And I'm absolutely sure that you have seen this wave at the sea or at the ocean. Such movement in the ground. This movement is such as in the water. Only difference in the density of those materials. Rock or other ground materials are moving in the same wave, in the same way as the water at the ocean or at the river or at the sea. When we are analyzing those impacts, we have to those seismic impacts that we have to understand that our building that we are designing on the earthquake impact. So this effect that we are analyzing on the building or structure during the earthquake, those movement consist of various waves on the surface, and those deformation leads to various effects in those structural elements which we as structural engineers have to design on those combined impact. So here is P wave, here S wave, here is relay wave, and here is lava wave. So those combination of wave we have to take into account when we are designing our structural elements and our buildings. So further, we will return to that question. But right now, you have to understand that all seismic waves are divided in two main groups. First group is body waves, and body waves consist of two waves. P wave, it's horizontal movement in the direction from the direction of hypocenter and epicenter towards to construction sites, and S wave is the shear wave which leads in which can be into horizontal or in vertical direction. Both S waves and those shear waves also moves from epicenter to construction site. But when we are talking about surface waves, we have to know that they are also consider those that group consists of two waves. Mm, Lava wave and relay wave. Relay wave is this movement in this direction, in vertical direction, and lava wave is the horizontal, like snake movement of the ground particle. So uh, here are four of the seismic waves that we have to consider. And do you have any question about this topic? Is everything clear? So, окей. Тут so Vova Ekel, I heard you. Why haven't you answered that when I was asking you? Екель, ви мене чуєте? Ну тоді готові відповідати на запитання по минулих лекціях? Так, зрозуміло. Ну добре, зато правда. Так, рухаємось далі. Якщо if you have understood everything, then I will discuss with you one more important question. But first of all, I will describe you in a few words. Later today, we will discuss the devices that we have to use to define the seismic activity or the seismic impacts of earthquakes on buildings. So here is one simple device that can be used to record the seismic impacts. Here is another one. I will show it for you one time. It is modern. It is really expensive device to define acceleration of earthquakes or acceleration of various various building elements which are imposed to earthquakes. Later, I will describe you how I'm using this device. So devices which helps us to record the earthquake impacts. And I want to ask you, do you know when was invented first device for earthquake analyzing? When was invented first device for earthquakes record or earthquake impacts analyzing? Any ideas? Yeah, so nice to hear you. Yeah, it was invented. Can you answer my questions on about previous lectures? So I'll ask you the next time. So today we will analyze the devices which are used for earthquake measuring, earthquake effect measuring. And first, the device was invented in China by Chinese scientist John Heng, and he invented such device. Here you can see the hinging element, and when earthquake starts, these elements starts to move, and depending from the direction of the earthquake, these hanging element moves in this direction or in this direction or in this direction. And when this hanging element moves, we can see that this hanging element connected with dragon choose. And when choose and when it moves, it takes into action those dragon heads. And when it moves in this way, this dragon open its mouth, and a round ball falls out of its mouth to the mouth of the frog. So, for example, if the earthquakes moves in this direction, then this hanging element moves in this direction, and after earthquake we will find those balls in mouths of these two frogs. This device was invented only for one purpose. This purpose was to find the direction of the earthquake. Only one purpose was solved by this device. Next device is really familiar for you, as I think so. It is really close to this one, and this device helps. It doesn't work, so I'll show you main idea. So when the earthquake takes place, for example, this can be used for vertical movement. Oh, it's really old and it doesn't work correctly, but when earthquake starts, this sheet of paper starts to move. And when we have this vertical movement, according to this vertical movement, we will find this record on this element. I'll write it for you. So it will be like this. Yeah, you can see this. And this record will help us to define few very important data, or two very important parameters of the earthquake impact. So first of them is of that effect is 1 second. I'll press it down and fix it. Okay. This helps us to define the amplitude of the earthquake and also the period of earthquake. So those two parameters gives us an ability to define these many very important parameters of earthquakes. Here you can see it like this. Okay. And seismographs have very many variations. So simpler seismographs looks like this. So when the earthquake start, this pendulum element fixed to this position because it is under the influence of gravitation. But the rest of this element moves in this direction, so we can find this seismogram. It is the record of the seismograph on this sheet of paper, and later we will be able to analyze that record in this direction. Same situation with the record in vertical direction. Here you can find this pendulum, which is hanged on this element to this element, and when earthquake takes place, this element stays stable, and the rest of this device moves in vertical direction. And after that, we will find one more record of the same earthquake, but in vertical direction. If we will add one more this device, but we will rotate it in this direction, we will get another one record of the same earthquake, but in horizontal direction. As I told you previously, when we are considering earthquake, it is vertical direction, it is horizontal direction, and it is horizontal. It has horizontal movement in this direction. So this combo of movement of the element during the earthquake can be described with three records. In horizontal in one direction, horizontal in other direction, in horizontal in vertical direction records. Those records describes us the impact of the earthquake on the structure or structural element. Those direction, those record is the record of displacements. But displacements are not the main parameter which we have to analyze when we are considering earthquake effects. So another simple seismograph we can analyze. It's John Milne seismograph. And let's consider its device. So first of all, we can find that vertical element, those vertical stud with pivot motion. It can move. It can move in this direction. Suspended mass, which, as I told you previously, connected only with the impact of the gravity, so it stays stable during the earthquake when the rest of this element moves in horizontally. And you can find here the hole in a thin plate, which gives the ability to light off this lamp, stay to leave the record on the photosensitive paper. It's like a photo paper. So after the earthquake, we will find this sheet of paper which have record on, but not of the pen or other element, but the record of the light of on the photosensitive paper. And this gives us an ability to analyze the seismic impact at certain part of our planet. So, is it clear how a seismograph works according to this slide? Okay. So, and here you can find the more difficult or more advanced device, which gives us an ability to make a record of the earthquake. And here you can see the 3D record of the particle movement, of the ground particle movement during to the earthquake, its direction, movement in this direction, and in this horizontal direction. So here is the movement. Here is the result of earthquake impact. And here you can find the here you can see the record, 3D record of an earthquake impact. So, and you can see that in this case, we can see one splash of deformations of the ground, and another one splash of deformation. That is one earthquake. That is not two earthquakes. That is one earthquake. But first of all, we have make a record of P wave because it is the fastest seismic wave, and then we have found the impact of the same earthquake, but it is the second wave. So, and here you can see the distance between P and S waves. That gives us an ability to define the distance from our construction site to the source of an earthquake, to the hypocenter and epicenter of the earthquake that we have recorded. Because when we are talking about records of seismograph in the hypocenter, not in hypocenter, in epicenter, there is no distance between P and S wave. Why is that so? Because both of those waves, P and S, influences on our device, on our building simultaneously. All seismic waves act simultaneously at the epicenter. So next device, it is most important for structural engineer device. It's accelerometer. When we're talking about seismograph, it is we have to know that seismograph is the device to record the displacements. One more device which I'm not considering during our courses, during our course, called velociograph, which measures velocity. And the most important for us as structural engineers is accelerometer. Accelerometer is the most important device. Why is that so? Because it makes the records of accelerations. And accelerations for us as structural engineers is the most important information, because we are calculating and designing our buildings on seismic forces, and we know, we have to know that seismic force is the result of equation, of simple equation, m mass of the element multiplied on acceleration. So seismic force in this stud equal to the mass of this ball multiplied on the acceleration which I gives to this element, and same situation to this element. So one more time in Ukrainian to make it clear for you. So для того, щоб вимірювати ефекти землетрусу, ми повинні знати ті прибори, які використовуються для цього. Перший прилад, яким ми користуємося, це сейсмограф. Сейсмограф надає нам можливість записувати зміщення у часі. І це є записом землетрусу і записом тих зміщень, що виникають під час землетрусу. Наприклад, сейсмограф Джона Мілна, він виглядає таким чином, і коли стається землетрус, рухається усе, і лампа, і ці стрижень, і ці барабан. Лише ця підвищена маса, вона не рухається, бо на неї впливає лише гравітація. Саме тому, коли стається землетрус, під час землетрусу зсувається барабан з лампою, а цей стрижень, він залишається відносно у стабільному стані. Саме тому світло від цієї лампи, що відображається від дзеркала, залишає на світлочутковому папері свій запис, який ми можемо потім аналізувати, і з цього запису ми можемо визначити амплітуду, найбільше зміщення, і період коливань землетрусу, щоб розуміти, які резонансні ефекти можуть від якої частоти можуть виникнути резонансні ефекти. Запис руху частки ґрунту під час землетрусу і три записи. Власне, тут інтересний факт. Цей запис зроблено велосіографом. Але незалежно від того, ми бачимо спочатку пі-хвилю, потім С-хвилю, і те, що між ними є дистанція, каже нам про те, що ми зробили цей запис не в епіцентру, бо в епіцентрі ці дві лінії пі і С-хвиля, вони будуть майже одночасно впливати на нашу конструкцію. І наступний прилад, який використовується для вимірювання по характеристик землетрусів, це акселерограф, і він робить запис прискорення в часі. І саме прискорення для нас є дуже важливим, бо сейсмічна сила є результатом множення маси на прискорення. Тобто маса цієї кульки на прискоренню, що я придаю рукою, і буде визначати ту сейсмічну силу, що впливає на цей стрижень. По приладах для вимірювання землетрусів, чи є до мене якісь питання? Так, Костянтин. По затуханню, так. Коли закінчилося перший сейсмічний вплив, він майже затух, і потім здається, що прийшов другий сейсмічний вплив. А насправді це не другий сейсмічний вплив, це прийшла С-хвиля. А ви питаєте, як відрізнили, що це саме С-хвиля, а не два землетруси? Для детального аналізу цього нам недостатньо одного приладу. Нам необхідно аналізувати декілька приладів, і коли ми на одній лінії реєструємо спочатку одну хвилю, а потім іншу, то ми тоді можемо зрозуміти, що це не одне, що це одне і саме те й саме це є один той самий землетрус у епіцентрі і далі, далі, далі. Таким чином було виконано цей аналіз. Це не є зіставлення одного запису, це є результатом зіставлення декількох записів на різних приладах. Are there any question? Any more? No more questions. And today we'll start another very important topic, how to assess an earthquake. Today we will start from Richter scale, and later next week we will discuss another type of seismic scales, intensity scale. So to assess the impact of earthquake, we have two various parameters or two various scales which helps us to define the earthquakes, the level of intensity of an earthquake. So those two parameters are really important for us, but it is not necessary to find the connection between them. It's like mass and height of a person. It is normal for example, for a person with the height 180 centimeters to have a weight 80 kilograms. It's norm, but in some cases, even a person with a height 150 centimeters can weigh 100 kilos. So it's not regular situation, but it can occur in some cases. Same situation with the parameters of earthquakes. They are measured and defined in various ways. So first way to define the parameters of earthquake is to use a Richter scale. A Richter scale is the scale which measures seismic energy. This scale gives an ability. This Richter scale gives an ability to measure the displacement and compare it with the distance from the source of earthquake from hypocenter, and from the ratio between the displacement and distance to the source of earthquake to define the seismic energy. So it looks like uh, throttle equivalent to the blast. So never it's not connected with the material. For example, you can blast TNT or you can blast C4. And nevertheless, all those explosives can be compared in total equivalent. So when we're talking about Richter scale, it's like throttle equivalent for the blast. But this equivalent gives us an ability to define the energy in the hypocenter, the seismic energy in the hypocenter. So it's not connected with the distance from the hypocenter. When we are analyzing the consequences of the earthquake, we know that sorry, as far we move from the epicenter, the less destruction we will find from the earthquake. Yeah, near the center of near the epicenter and near the hypocenter, we will define the most destructions, but from on a distance 100 or 200 kilometers, you will find less destructions of the buildings. So but nevertheless, at the center or destructions or on 200 kilometers, the seismic energy is the same, which was emitted from the hypocenter. So earthquake magnitude is the measure of soil displacement or displacement of medium particles obtained from seismogram. And it's like this. So here we can see the hypocenter, and at the epicenter we will find the most displacement. On the bigger distance, for example, 100 kilometer, you will find this displacement, and on the distance, for example, 1000 kilometer, you will find this displacement. So nevertheless, you are defining the displacement on this direction or at the epicenter, you will find this same value of seismic energy which was emitted from the hypocenter. So and these and Richter scale is devoted to the comparison of this displacement, to the ratio of this displacement with the distance from epicenter, and this displacement from this distance to the epicenter. And nevertheless, you have defined displacement here or here, you will find the same energy which was emitted from the hypocenter. So here is the contemporary seismograph, which records the impact of an earthquake on large distance. And here you can find another important information about earthquake. It is energy and ergs and magnitude. And here you can find the ratio. And you have to know that one magnitude differs from the other in 30 times the energy which was emitted from magnitude 6 to magnitude 7 equals 33. And if you will compare magnitude 6 with magnitude 8, the difference with ergs will be 1000 times. 1000 times. So one more in Ukrainian. So, для того, щоб оцінювати сейсмічні впливи, в нас є дві групи шкал. Це є шкала Ріхтера, вона оцінює сейсмічну енергію, і шкали інтенсивності. Спочатку ми аналізуємо шкалу Ріхтера, це є як тротиловий еквівалент від вибуху. Магнітуда вона визначає співвідношення між сувом у якійсь певній точці з дистанцією до гасла землетрусу. І в незалежності від того, ми реєструємо коливання у епіцентрі або на дистанції у сотні кілометрів, ми визначимо саме однакову сейсмічну енергію, тому що аналізується не лише абсолютна величина зміщення, а аналізується співвідношення між зміщенням та дистанцією до гасла землетрусу. І так воно виглядає, тобто на дистанції у епіцентрі зміщення 10 см, на відстані 100 км, наприклад, 1 см, а на відстані 1000 км 0,1 см. І відповідно до цього співвідношення ми можемо визначити саме, яка кількість енергії була у гаслі землетрусу. Цілі магнітуди, вони зміщення між цілими магнітудами дорівнює 100 разів. Тобто при магнітуді 6 зміщення буде в 10 разів більше, ніж при магнітуді 5. Тому магнітуда 5 та 6 вона дуже суттєво відрізняється. А якщо вимірювати не по зміщенню, а по енергії, що виділилося у гаслі землетрусу, то магнітуда 5 від магнітуди 6 відрізняється у 33 рази, а магнітуда 5 від магнітуди, наприклад, 7 відрізняється у 1000 разів. Тобто ви розумієте, що якщо кажуть, що стався землетрус магнітудою 6, а потім 7, то той землетрус з магнітудою 7, він не трішки більший. Зміщення в 10 разів більше, а енергія, що виділилася з гасла землетрусу, вона у 33 рази більше. Таким чином, на сьогодні ми будемо закінчувати тему, що пов'язана з шкалами землетрусів. Сьогодні ми з вами дослідили шкалу Ріхтера. And to summarize our lecture, I will remind you that during our lecture today we have considered surface waves, and you have to remember that all seismic waves consist of two groups, body waves and surface waves. And today we have discussed the topic connected with surface waves. You know that there are two surface waves. First of them, lava wave. It's like a snake movement of the ground. It's near the surface. And another relay wave. It's vertical. It's a seismic wave in vertical direction, which leads to this deformation of the ground particle during the earthquake. Combo of those waves is also very different, and it is more dangerous compared to P and S waves. Next step for us for today was to start topic of seismic scales, and today we have analyzed Richter scale. Richter scale is the scale which measures seismic energy, and it is really important for us to know which amount of energy have was emitted from the hypocenter to analyze and to compare the earthquakes between each other. And also, we have analyzed today. We have analyzed devices for assessment of seismic impacts. First of them is called seismograph, and it measures displacement. And second is called acceleropograph, and it measures acceleration. So that's all for today. Are there any questions? So thank you. See you next week. Bye.